Hello, my name is Maura Reed, and I'm a sixth-year PhD student in the Department of Earth and Planetary Science at UC Berkeley. If you live in the Bay Area, you're probably used to thinking about earthquakes, and we tend to think about them in terms of their effect on people at the surface. But earthquakes also affect the ground beneath our feet. The passage of seismic waves can affect fluid flow in Earth's crust, which means earthquakes can affect everything from streams to groundwater to even volcanoes, and geysers, which is what I study. Geysers are interesting to scientists because they make for good volcanic analogs, and since they're smaller and erupt more frequently, they're a lot easier to study. I am broadly interested in the factors that influence when and how geysers erupt, with a focus on Yellowstone. We have plenty of documentation that large earthquakes affect geysers. For example, the 1959 Hebgen Lake earthquake immediately triggered eruptions in the majority of geysers in Yellowstone. It even resulted in the formation of new geysers, but started as a patch of steaming ground in 1960, developed into a fully fledged geyser by 1963. The park geologist named this seismic geyser because of its origin. But what do smaller earthquakes do to geysers? We identified a potentially earthquake-triggered eruption of Steamboat Geyser, which erupted 8 hours and 15 minutes after a magnitude 3.9 earthquake in September 2022. Steamboat's a pretty special geyser. It's the tallest geyser in the world, with maximum eruption heights of 450 feet. That's 1.5 times the height of the UC Berkeley Campanile. It also alternates between periods of dormancy and activity, and it's been in an active phase since 2018. It's hard to imagine that subtle shaking could induce such a large geyser eruption, but it's unlikely that the two events happened on the same day by chance, based on Steamboat's usual interval between eruptions. We looked to seismic data to find more evidence that the earthquake actually affected the hydrothermal system. Here we've plotted the strength of seismic noise from geysers in the area, and we found that there was a signal around 1 hertz that suddenly jumped up slightly in frequency and got weaker right after the earthquake. We also compared the peak ground velocity generated during this earthquake to all the other earthquakes that occurred since Steamboat reactivated in 2018. And we found that this 1.2 centimeter per second velocity was the largest of all of them. Our analysis indicates that the magnitude 3.9 earthquake probably did trigger this particular eruption, but there are still outstanding questions. Large earthquakes, including the Hebgen Lake earthquake I mentioned earlier, have not caused Steamboat to erupt, which might mean that a geyser's internal conditions do matter. We need more examples of earthquake-triggered eruptions to investigate that more. To identify those triggered eruptions, we're going to need to implement a lot more geyser monitoring, and I'm really excited to work on that during the rest of my PhD. Thank you.